So today I am down here in my wiring closet taking a look at what is wired to where. Even though it may look neat and everything is connected very nicely, I don't actually know what jacks up on the patch panel get plugged into which ports on the switches. Sometimes I don't even know which switch they're plugged into, and that's a bit of a problem. So I want to get started with infrastructure as code, and that's not the topic of this video. The topic of this video is NETBOX. NETBOX is a tool that helps you organize how everything is connected in the physical space and the virtual space of your network. It's designed to be a ground source of truth where how things are actually connected and how you're planning on connecting them can all be documented, and then you can use that as a place where your infrastructure as code tool can pull from that data and know that it's accurate because someone has spent the time to manually verify that everything on the patch panel is actually plugged into the right place on the switch. You can add what labeling you're using. All of that sort of stuff can be tracked in NETBOX. So if organizing the physical layer of your network sounds good to you, then come along on this adventure. So before I throw you guys into the process of installing this stuff, let me give a demo of just how useful NETBOX is for keeping your network organized. So this is what my NETBOX homepage looks like. We've got all the different categories we can organize. Organizations, this is stuff like sites, tenants, contacts, people, locations, regions, etc. Racks, devices, connections between devices, wireless LANs, IP address managements. We can manage subnets, prefixes, ASNs, aggregates, etc. VPNs, virtualization, power circuits, or actually these are data circuits, and then power circuits, provisioning, etc., configurations, and I guess administration. So NETBOX is really big on their data model. Essentially, every object in NETBOX has a type. It could be a device, it could be a rack, it could be a site, etc. Those have certain attributes. You can template them based on other things. So a device could be based on a manufacturer's model of a device. So I could have a manufacturer called MikroTik. I have MikroTik switches. From the MikroTik manufacturer, I can create a device type, such as a CRS328, which is the switch I have in the basement. That device type, for example, might have ports with specific numbers, specific bandwidths already configured. Then when I create an instance of that device, I put it in a rack at a specific location. I can match what all of those ports are patched to, etc. So digging into that here, I have one site. I just called it home because it's home. At my site home, I could have filled in all this stuff, but I don't want to show you guys my address, so I didn't. But I have one rack. That one rack is called the main network rack. It's 12U. So I dig into here. I could put all of this sort of information in. Airflow direction, asset tag, serial number, all this stuff you can keep just for yourself. You can also take pictures of the rack. So I float over these. You can see I added pictures. This is just helpful for techs that have to come in and work on this stuff to see what's going on. Scrolling down a bit, it's automatically populated this drawing of the rack. So all of these are front only, so they don't show up on the rear as well, but you can have servers that go all the way through. So I've got patch panel 1A and 1B, patch panel 2, patch panel 3, 2 patch boxes, 3 switches, and a shelf. And then that takes me down to devices. So on devices, I have all of the objects in the rack. So for example, this guy here, patch panel 1A, I can click on him. He has front ports and rear ports. So on the rear ports, I can see how these things are labeled. So for example, these guys, punch 1, etc. I just named that punch because I thought it was a good name. It's a 110 punch type, etc. I could say what type of cable it is, etc. And those ports are connected to their corresponding front ports. And from there, that can get connected to, so for example, this guy here, front 5, he's front room TV, he's connected to ETH17 on switch 1. When I click on this, it takes me right to that switch. So you can see that switch has 28 interfaces. On the switch, they're named ETH1 through ETH24 plus the SFPs. And I can see what VLAN they're on. In this case, they're all on Homeland 10. So zooming out a little bit so my icons over here show up. For example, I want to see where ETH6 goes. I have no idea where it goes. I can go over here and hit trace. Now that's pulled up a trace of all the devices this cable connects through. So in the end, we have punch 20, which is studio camera. That is on patch panel 3, which is a generic Keystone patch panel. It tells me it's on port 20 of that patch panel, and it's on U9, so that's rack unit 9. That's connected via a cable, number 28, to ETH6, which is this specs at rack unit 6. So if you take the time to put the data in here properly, This is an extremely accurate representation of how everything is wired. If you use any sort of numbering scheme for any of your wires, any of your drops, etc., you can put all of that in here and respect it correctly. So that anytime you see a cable with a number on it, you can go in the NETBOX and see what is that cable, what is it connected to, what is the end-to-end path of that wire. And NETBOX knows all that stuff. It's cool. But of course, there's more than just cabling. So here I've got some other columns showing up so I can see what type they are. Are they SFP plus 10 gig, copper 10 gig, etc. Or this guy's just 100 meg, he's management port. But I can also see what VLAN mode I'm using, what VLAN I'm on. So this switch, all the ports are tagged because they're all important. But if I follow one of these guys down to switch 1, so switch 1 has a lot of untagged traffic. So I can see this is an access port and it's on VLAN 10. And then I click on VLAN 10 and I can see what ports are assigned to VLAN 10. So in this case, all of these are untagged, so they're access ports. ETH 1, 2, 3, 4, 5, 6, all the way down to ETH 24, and then Combo 1 and Ether 6 on switch 3. Those are all assigned to this VLAN. And it supports VMs as well, so I could have virtual machines on this, as well as physical interfaces. Those are all tracked. So being that I've only been using NETBOX for about a week, I have just barely scratched the surface of all the cool stuff this can do. I'm also doing this for a home network, so it's not the most complicated setup. But if you do business sort of IT, NETBOX is really easy to set up and will probably provide a ton of value to you. So anyway, how do we set it up? So as usual, I have all the instructions on my blog down below if you just want to copy and paste all these things. And I'll go through it with you, of course. Now before we get too far along, there's quite a few things we're going to install here. So NETBOX itself is written in Python using the Django framework. If you download the Docker image, you basically get just NETBOX and Gunicorn, the WSGI server. That will get you NETBOX serving an HTTP request, but it won't get you a database in the back end. For that, we need Postgres. Postgres is super easy to install. I'm going to install it in the same LXC container that I install NETBOX in. In addition to Postgres, we also need a cache, and for that they use Redis. So we need Postgres, Redis, NETBOX itself, Gunicorn, which comes with NETBOX, and that will give us plain HTTP. So we probably also want HTTPS as well. And so I'm going to add caddy on front of that as a reverse proxy to do TLS termination for this server. So that's 5 things we're going to install, or 4 I guess. Gunicorn and NETBOX are kind of together. So let's get on that. So just starting here in my Proxmox system, I'm going to go ahead and make a new container. It can be unprivileged, that's perfectly fine. Let's start with the current version of Debian, Debian 12. I'm going to say 64 gigs and just put everything here. If you're going to upload a whole bunch of pictures, you might want to make this drive a little bit bigger because all of your user uploads end up here as well. Or you can make a second mount point on slower storage if you want your pictures somewhere else. Pictures aren't that big anymore, so 64 gigs is probably perfectly fine. 2 cores sound good. 2 gigs of memory, probably fine. See, we just need IPv6. We don't need IPv4, so we'll just turn that off. And let's go. Just going to do the usual upgrade just to make sure we're all ready to go. While this works, by the way, and does updates, we're going to be doing apt update a couple of different times. So I have separated the instructions into Postgres and Redis and Python. If you want to just do all of the apt updates at once, maybe I'll put that in the blog too, but I separated them so you can follow along better. Okay, we're all good. According to my instructions, we're doing Postgres first. So we can just install Postgres and sudo. Now after we install Postgres, we're going to run PSQL as the Postgres user. So this means sudo execute as user Postgres, the command PSQL, and then copy and paste these lines in one at a time. This is going to create a database for NETBOX. It's going to create a user for NETBOX to access Postgres. Probably should pick a better password there. And it's going to give the user NETBOX permissions on the database NETBOX. Done. So copy these guys one at a time into PSQL. They were done. Create database NETBOX. Create user NETBOX with password. Correct source battery staple. Alter database NETBOX owner to NETBOX. Connect NETBOX. Grant and quit. All done. And Redis is also pretty easy, so we'll just install Redis server. And we can test it by running Redis CLI ping. And we get back Pong. So those first two steps were not that hard. Next, we're going to clone the Git repo for NETBOX because it's entirely in a Git repository, and set it up. So we got to install a bunch of stuff this time. Python 3, pip, virtual environment, build essential, libxml. What else are we installing? A bunch of other libraries and Git. Then we are going to git clone NETBOX into opt. So opt, we're going to add a user called NETBOX. It's a system user. We're going to give him ownership of the folder opt netbox, netbox, netbox. They like to nest netbox, so we end up with stuff in opt netbox, 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 configuration. And that's our config file. So I'll just copy this whole thing and we'll run that. So next up, we're going to need a secret key. So we just call this guy to generate the secret key. Then we're going to edit the configuration. So it looks like my key today is that guy. I'll just copy that off screen. So this is in diff format, by the way. So minuses are lines that get deleted, plus are lines that get added. So this means that this is what the line looked like originally, and this is what the line looked like now. So you can see essentially I'm changing each time there's a plus or a minus, I'm changing something. So first thing we have to change is allowed hosts. So NETBOX, like many sites, does not take kindly to cross-site resource forgery. So to prevent that, you have to add all of the domain names you're going to use to access NETBOX into this array here. So that's my example there. If you're going to use an IP address, you can put that too. So scrolling down a bit, we've got our Postgres stuff. So the database name is NETBOX, the username is also NETBOX, and the password I used today was correct horse battery staple. Probably should pick something better, but it's easy to remember. For Redis, we don't actually need anything. And we need that secret key that we copied and pasted earlier. And what else do we got? Optional settings. Okay, we can just quit now. So having done that, we call this script called upgrade, which actually does the install if it's not already installed. So let's just tell it to go ahead, and it's going ahead. In the future, to upgrade NETBOX, just do a git pull, so you sync with the repository in GitHub, and then run this upgrade script again, and it will upgrade like the name says. But if it's not already installed, it will also install it for you. Okay, so it says, warning, no existing environment is detected. If this is a new installation, this can be ignored. So we are all good. A couple more things though. We need to set up this timer to run housekeeping daily. Just paste that command in. It's just going to call this housekeeping script every daily from cron. We also need to create a super user. So we're going to jump into the virtual environment and then call create super user. So now we are in virtual environment. Then we're going to change to opt netbox netbox and then create super user. So we can give him a name. I'm Appelard. Okay, got a super user. While we're in the virtual environment, we can also test it by saying manage.py run server 8000 insecure. So now this guy is going to start up temporary server so we can test it. And there we go, we're at the login page. So now that we've proven it works with the development server, we're going to install a proper WSGI server that's Gunicorn. This is not that hard. All the commands are already here. We just copy and paste them. I'm going to deactivate to get out of the V environment. We've got 3 files here. 2 of them are systemd units. And so that's going to be our NETBOX and NETBOX RQ systemd units. So paste that guy in. And now these services should have started. So Gunicorn is now listening on 8001, but only on localhost. So we have to proxy it somehow. So when I install services in my home lab, I kind of treat the LXC container as a pod. So in the pod, I'm installing all the dependencies of the service. So in this case, NETBOX itself, Gunicorn, but also its databases, so Reddit, Postgres, all of those can live together. I'm not hitting Postgres hard enough to need to separate it out and run it separate in a cluster or anything like that. It's not doing a lot of heavy lifting for NETBOX here. Or rather, NETBOX is not handling so much load that I need a separate database server. So they're all contained in their pod. And part of their pod, I also run a reverse proxy. So in this case is Caddy. So with Caddy, requests can come in over HTTPS securely. If I do any sort of authentication, I can do it here. With Authelia, I have a video on Authelia, or with mutual TLS, I have a video on mutual TLS as well. And that will proxy all the requests to Gunicorn locally. Also, this will directly forward static requests. So static files in the static directory just get served directly by Caddy. Now, some people like using ingress proxies for this. Some people like Nginx Proxy Manager, etc. Whatever. In this case, Gunicorn is set up to listen to localhost only. So some sort of proxy has to run on the same host. So I'm installing Caddy. And because Caddy's repos are more up to date, I have set up Caddy's Debian repos here. So we can run these commands here. This will install the stuff we need to install their repos. Then we can download the signing keys for their repos and also their list, their repository list. Then we can install Caddy from their repo. So just copy this whole thing. So now we got Caddy 2.9.1. I also gave you guys a Caddy file. This is what I use. So for handling static, I just take that straight out of NETBOX. And for everything else, it's on localhost 8001. And we can either do TLS internal or use a publicly signed Let's Encrypt cert. I use the publicly signed Let's Encrypt option. That's because I allow IPv6 through my firewall to these public destinations so I can get to them. That way HTTP challenges work just fine. If you're in a more restricted environment, you might have to do something else. Or use TLS internal, that's fine too. So just blow away the old Caddy file. Paste in the new one, save it, yes, done. So now we restart to get the new config, and we should be good to go. Also, make sure you change this name to what you actually want your cert to be, otherwise it won't work. So we get the potential security risk because it's self-signed, and there we go. Now we're off. So anyway, that is how to set up NETBOX. I don't want to pretend to be an expert in how to actually use NETBOX, but hopefully you guys can fill me in on some of the tips that you guys have for actually using NETBOX and for how you guys do infrastructure as code. So I'm planning on trying to set up my switches to auto-configure their VLAN assignments from NETBOX. That's sort of my next step here. So I'm putting in all the cabling, putting in all the VLANs in here, the VLAN IDs. I want to be able to pull the list of what interfaces should be tagged and untagged from NETBOX, have the switches configured themselves, so I don't have to go into Winbox and configure it. Now the Winbox is hard, but I want it to be automated. That's my first step in automation that will happen eventually in the future. So yeah, like and subscribe if you guys want to see that. I have a Discord server linked down below if you guys want to chat with me any more about this. I have a Ko-fi too. It's kind of like a Patreon, but it's only a one-time thing, and I really appreciate that. And as always, I'll see you guys on the next adventure.